So with that, I'd like to present Vani Mandava and her colleague Jeff Prosise. They'll be talking about Microsoft Azure for research, bringing the power of the cloud to big data. Vani is the director of the data science for a research effort at Microsoft Research in Redmond. Her role in the Microsoft Research Outreach team is to enable academic researchers and institutions to develop technologies that fuel data-intensive scientific research using advanced techniques in data management and data mining. She holds patents in service infrastructure, and after spending the bulk of her career in engineering, finds it fascinating to work alongside researchers and scientists. And Jeff Prosise is the co-founder of Wintellect and a software developer who has written 9 books and hundreds of magazine articles, trained thousands of developers at Microsoft, and has spoken at some of the largest software conferences. In his former life as a mechanical and aerospace engineer, Jeff worked at Oak Ridge National Lab in Lawrence, Livermore, where, among other things, he developed software and combined thermal and structural finite element methods to model optical systems for high-power laser beams. Scientists have laser beams. I love it. Today, he is thrilled and somewhat amazed that with a few button clicks in the Azure portal, he can spin up an HPC cluster almost as powerful as the craze he used to work on. I love it. Well, and I want to say a big thank you to Vani and the Microsoft team, because they are providing Microsoft Azure credits, in total 750,000 Azure credits to the South Hub, 3 million across all the hubs, and they'll tell you a little bit about this in their presentation, and we will be rolling out the how you can apply for those credits in the coming weeks. So with that, Vani and Jeff.
All right, thanks. This is Jeff. Vani, would you like to just say a word or two to start us off, then let me go over to the slide deck?
Yeah, absolutely, Jeff. Thanks to the South Big Data Hub for this opportunity to present to the community. We're excited for the partnership, Leah and Stan, and we look forward to what's going to come out of this collaboration that we have with the Big Data Hub. Jeff is going to give you an overview about Azure and how we're using it for research, and I'll do a deeper dive on the big data aspects of Azure and some of the successes that we've had out of the programs that we've run over the last 3 years.
Fantastic. And I have a slide deck up. If you could make me the presenter, I'll share my screen and hopefully everyone can see it.
Thanks, Jeff. You've been given the presenter ball.
Okay.
Top left-hand corner, you may see File, Edit, Share.
Yes. And share my screen. Perfect. So, Carl, that's coming up now. And can you just confirm that you can see a big blue slide that says Microsoft Azure Overview?
Yes, indeed.
Fantastic. Well, thanks for giving to talk to you today. As Vani said, I'm going to spend 10 to 15 minutes just with not so much a general overview of Azure, but an overview of it, what it is, with specifically the intention of addressing some of the things that it does for data scientists, some of the services that it offers that might be useful to researchers. Then she's going to talk more about the program she runs at Microsoft, how to apply for the credits and things like that. Well, let me just start by asking a question, and that question is, what is the cloud? Kind of a silly question, especially for researchers who have been using it for a long time. But I often begin presentations like this with this slide because it's an interesting way to ask people to think about what the cloud was just a few years ago. When I was first introduced to the cloud, it was about storage, and it was about infrastructure like virtual machines. It was about storage and compute. And a lot of people still think of it that way, but the cloud is so much more today. What's really happening in the cloud these days is software as a service, where very high-level services encapsulating machine learning, stream analytics, stream processing, and things like that are basically made available to you with a button click. In the introduction a moment ago, Leah said, I find it amazing sometimes that I can go into the Azure portal and spin up an HPC cluster that's very, very comparable to the craze I used to work on back in the 1980s. That's what I find most interesting about the cloud these days, the fact that it's making incredibly vast compute resources available to us that would have been next to impossible to get a hold of several years ago, and the fact that they're building software as a service offerings on top of that make it easy to do the things that might not be so easy otherwise, get access to HPC clusters, Spark clusters, and things like that. Wanted to throw just a few numbers in there, not because the numbers themselves are important, but just to demonstrate the scale of Azure as a cloud platform. Think about what it would take if you were going to build out the infrastructure for something that would process 777 trillion storage transactions per day. That number has gone up. By the way, we haven't updated this slide in a few months. That's just a massive number of transactions. What's interesting about the cloud these days is that it offers an economy of scale that was unthinkable just a few years ago. The reason Azure can do what you saw in the previous slide is because there are currently 34 data centers online, with 4 more that have been announced, and in some cases are actually under construction right now. If you have tracked the development of Azure, you know that just a year ago that was 24 data centers. Microsoft is literally investing billions of dollars in building data centers around the world. Most of these are public data centers, but some are not. In certain countries, local laws and regulations require data to not cross the boundaries of the country, so essentially we stand up private data centers in those countries. There are Gov data centers too, which are only available to Gov customers. But with this kind of infrastructure and the kind of throughput that you saw in the previous slide, the big message is that we can deliver an economy of scale that would be very, very hard to duplicate yourself. In our role, we often talk to CTOs of companies who are trying to decide whether to move to the cloud or not. They often say, well, you know, we have these data centers, we have a large investment in them and stuff. But when we show them the map, we talk about the investments that have been made and talk about the economy of scale, how with the cloud you're not having to pay to keep that infrastructure maintained and upgraded and things like that. That usually paints a picture that makes them think that this is at least worth considering. Now, Azure itself has most of the services that you would expect from a cloud platform. You can spin up virtual machines. There are lots of different types of VMs you can spin up. Some of them cost as little as 7 cents an hour to run. Some of them cost many times more. You choose, for example, the number of cores, the types of cores, the amount of RAM, the number of disks, whether they're SSD drives or what have you, and basically can create these virtual machines to do work on your behalf. If you want to network those virtual machines to create HPC clusters from them, that's easy to do too, often just a button click because of something called Azure Deployment Templates, which is one of the mechanisms that Azure gives us to essentially script the creation of Azure resources. What's really interesting to the research community, though, is what you see in the center of this slide. It's not so much the compute resources and the storage resources themselves. It is the data services that Azure offers, which utilize those lower-level infrastructural services. For example, HDInsight is Microsoft's name for an Azure service that makes it very, very easy to spin up clusters of virtual machines pre-installed with members of the Apache data ecosystem, like Apache Hadoop and Apache Spark and other things. I'll say more about those in just a moment, but also under Analytics and IoT there in the center, you see Azure Data Factory, Azure Event Hubs, Azure Machine Learning, Stream Analytics. I'll be talking about some of these and more, but as a researcher, this is probably the part of Azure that's going to interest you the most. Again, under the hood, a lot of the infrastructural services are being used. For example, when you create that HDInsight cluster with Spark and Hadoop and Hive and HBase installed, yes, it's running on Azure virtual machines. But with the future of the cloud being software as a service, where it's not just about managing the VMs yourself, but clicking a button and creating resources that already have software pre-installed, et cetera, that's where things are going. Now, one of the things I want to mention, just because it's not something that we do a very good job of communicating sometimes, is that just because Microsoft builds and sells this product called Windows doesn't mean that there's a strong tie between Azure in Windows. In fact, when you go in, you create a virtual machine in Azure, you have a choice in most cases whether to make it a Windows machine or a Linux machine. And to be honest with you, much of the effort and the work that's going into Azure today is not around making it a better platform for Windows, but it's making sure that it runs Linux and members of the Linux ecosystem very, very well. So we like people to know that just because it's Microsoft, we're not necessarily tied to Windows. We are just as happy, if not happier, to host your virtual machines on Linux as we are with Windows. Now, just real quick here so I can get it over to Vani so she can talk about the data science program. I just wanted to make you aware of a few of the specific features and services of Azure that might be interesting to you as a researcher. For one, Azure has supported virtual machines for a long time. If you're interested in knowing what types of virtual machines you can create and cluster together, what the specs are, just do a search on Azure VM sizes. The most recent VM size or VM series that's been introduced is our N series of virtual machines, of which there are two types. There are NC VMs and NV VMs. Both of those are outfitted with in most cases, multiple NVIDIA GPUs. The idea here is that if you need an HPC cluster with GPU support, with thousands of GPUs if you want, because you can connect these machines together with RDMA and InfiniBand, then you can create a cluster as large or small as you want with those GPUs. In fact, Microsoft Research's UK branch recently worked with some folks at the Alan Turing Institute in the UK who used a single NC24 VM to do some computations that would have taken a lot longer on that researcher's laptop. NC24, by the way, has 24 cores, has 4 K80 GPUs, 224 gigabytes of RAM, and other things, so it's a pretty beefy machine. And in this case, the researcher was using that machine standalone, but again, we can network these things together and create GPU clusters from them. Another thing that might be interesting to you as a researcher, HDInsight, which I mentioned a moment ago. Many of the universities that Vani and I visit use Hadoop and or Spark, and it's not uncommon for the IT departments at those universities to build and maintain large and very expensive compute clusters. Then typically the faculty, the postdocs, the grad students will have to write proposals to get access to those clusters. And if you've ever, by the way, built a Hadoop machine or a Spark machine yourself, much less a cluster, you know how difficult that is. HDInsight, you literally go into the Azure portal, answer a few questions like what VM sizes do you want, how many nodes do you want there to be in the cluster, what software do you want pre-installed, you click OK, and typically 10 to 15 minutes later you come back and that cluster has been created for you. Azure Machine Learning, something that we're particularly proud of because machine learning, as you know, is figuring very prominently into data science these days. If you've never seen Azure Machine Learning, check it out sometime. It's a slightly different way of thinking about machine learning where rather than code everything from scratch yourself, we give you this browser-based tool called ML Studio where you build sophisticated machine learning models using a drag and drop paradigm, basically dragging modules representing algorithms, representing actions like various operations used to clean the data, even training the model itself, dragging modules out to a workspace and then connecting them together to define a workflow. What's really neat about Azure Machine Learning, and one thing that sets it apart, is once a model is built, trained, and evaluated, you're happy with it, a couple of button clicks operationalize that model by deploying it to the cloud as a web service with HTTPS reachable endpoints. That means I can then take that model and I can build software around it, whether it's software for my iPhone, software for my browser, for my workstation, or whatever, makes it very, very easy to operationalize the model. Something else that's getting a lot of attention today in data science is streaming data, dealing with the massive amounts of data coming from IoT devices and other places. Just very briefly, I want you to be aware that Azure has a service called Stream Analytics, which basically takes these high volume, high velocity, highly dynamic data streams and allows you to extract information from them using a subset of the SQL language that you're probably already familiar with. That language has some extensions in recognition of the temporal nature of the data. It supports windowing, for example, which is a pretty common concept in stream processing. Stream Analytics, like Azure Machine Learning, is software as a service, very easy to go in and set up and get it working. And just very, very quickly, because I want to get this over to Vani, something you might not have heard of is something that is technically not part of Azure, but in fact it has come out of Microsoft Research, is hosted on Azure, et cetera. It's called Microsoft Cognitive Services. It's a set of, right now, 24 APIs. It's grown by 3 recently, that help you build intelligent software. There is, for example, a computer vision API to which you can pass images by URL or in byte streams. It will analyze the images, identify objects in them, identify colors, caption the images, score them for adult content and raciness and things like that. There's a related API called the Face API, which will pick faces out of images and videos, and if you want, with a simple call, we'll compare that face to thousands or hundreds of thousands of other faces in a database you provide and tell you which other faces that face matches. Interesting project going on right now that's being run, I believe, out of Microsoft EDU, building a campus security system based on that. One other part of Microsoft Cognitive Services, just one of those 24 APIs, is the Text Analytics API. Kind of interesting. You feed it a text document or a Twitter stream or something like that, and it will analyze that data in several ways. It will tell you what language it believes that was written in. It will detect and identify topics and key phrases, and perhaps the most interesting part of it is it will do a sentiment analysis. It will, for example, return to you upon request a value from 0 to 1, indicating the sentiments being expressed. 1 being, hey, everyone's very happy who's in this Twitter stream, 0 being they're not very happy. Would have been very interesting to take the Twitter stream with #United last week and feed it into this API just to see how it turned out. And finally, one of the things we're very proud of about Azure is that we implement in it now, in a service called the Azure Container Service, a native Docker stack. Now, lots of cloud services support Docker. Most of them do that with a combination of open source and proprietary components. We have literally taken Docker, which is open source, implemented a native stack, which means if you want to take Dockerized or containerized applications and run them in Azure, you can do it natively. You don't have to do anything other than connect to Azure Container Service. Your Docker images don't have to change. You can still pull images from the Docker Hub or from other Docker registries. It just works. We actually support now, out of the box, 3 different orchestration services for it. So whether you prefer Kubernetes or DCOS or Docker Swarm, it's literally just a drop-down list in the questions we ask you before we deploy that service for you. One last thing, one reason that may be interesting is that one thing we hear from our customers at universities and research institutions time and time again is we like the cloud, but we don't want to be tied into any one vendor or cloud platform. One of the great things about containerized workloads, besides the fact that they are smaller, lighter weight, and faster than full VM workloads, is that it gives you that portability, because I can take a containerized app, I can run it on AWS today, I could be running it on Azure tomorrow, or vice versa. So if Docker is not something that's on your radar, or the container theory in general, it might be something you want to look at, because I think you're going to see that it not only plays a large role in Azure in the future, but a large role in the research community as well. And with that, I am going to turn it over to Vani. And Vani, I apologize, I meant to take about 5 minutes less, but I realize you are dialed in by phone. You can't see the screen. I'll do my best to flip the slides for you at the right time, okay?
Yeah, thanks, Jeff. I can view the webinar, so I can actually see the slides.
Good.
I'm going to quickly go over the programs that we have that we offer to academic researchers, and I'll dive a little bit deeper into the advanced analytics capabilities of Azure, because this is a big data hub community, and I think it's important to impress upon the community what we can offer in terms of research on big data workloads. So the data science program out of my team gives academic researchers data sets for research. That's the URL for it, aka.ms/data science. We have partnerships with the National Science Foundation, and a part of that is the $3 million worth of Azure credits that we have donated across the 4 big data hubs that we have talked about. We're also part of an NSF Big Data solicitation, and we're excited as NSF is moving away from traditional hardware-based grants to cloud infrastructure. We're excited to partner with them and see how we can empower the academic and research community through cloud computing. We also provide training. A lot of the services that Jeff talked about, need they are evolving very rapidly, and we provide training to the academic community and how to use them. So the next slide has a representation of how historically students were doing big data research. This is a slide from about 3 years ago from the University of Washington. They sent this to me as part of a proposal when they requested cloud computing grants from us. And it's very cumbersome. It has, and there are a lot of universities that still are on this model where students are, using laptops. Data sharing is hard. Experiments are taking a really long time. Fast forward about 3 years into the program, and over 1,000 grants later, we've had some real successes out of the Azure for Research program, as is evident in the case studies that we have published on our website. You can go to azureforresearch.com and look at the various successes that we've had out of the program. So the next slide has 4 such examples of academic projects that we have taken a deeper look at. One of them is the one that came out of the group in the previous slide, which is they have successfully used Azure to predict the risk of readmission for hospital patients using Azure machine learning. And this is actually a university project that's spun up into a startup, and we're doing really well. We're very proud of this project. There's been a few more such successes, both in academic and startup, and it's across multiple domains and verticals: healthcare, environmental science. There was one really interesting one where the professor at the University of Rochester is using Azure to help users improve their public speaking skills by just using a camera on their laptop to take a video that then gets analyzed, and using Azure machine learning, they can do sentiment analysis and so on. So why are we focusing so much on all these cognitive services and all this intelligence based on data? We believe that we are in the middle of this industrial revolution, which is known as the 4th industrial revolution. There's this proliferation. There's been a proliferation of small and expensive IoT devices and computers, and these devices are as ubiquitous as the people who use them. All these machines are everywhere and constantly creating and collecting a ton of data, and we hope to democratize this industrial revolution by providing the building blocks to empower the people who are collecting this data and organizations to use data as a key strategic asset when combined with the cloud and the intelligence capabilities that the cloud provides to automate, innovate, and increase the speed of doing research and business. To do that, we believe that there is this big digital transformation that drives business value and research impact through the use of these intelligent services that is built upon the cloud. So we can probably skip over the next two slides for lack of time and go straight to slide 21 in the deck. So there's this whole transformation, right? The digital transformation is taking you from data to insight, and we believe that analytics can go all the way from just descriptive, which is 20 years ago, you had data, you just generated reports out of it. This is some visual representation of the data, to diagnostic. Both of these are considered to be hindsight type of analytics, to predictive analytics, which is more insight-based analytics, to prescriptive analytics, which is actually going to predict and tell you what is going to happen. That's considered the holy grail of analytics. It's foresight-based of analytics. So you're going all the way from hindsight to foresight through this digital transformation. Again, there's this really fun graphic that I don't know, you might have seen people at Microsoft present, which is known as the Rice equation. We expect that by 2020, all these devices and users are going to generate 40 zettabytes of data. So if a single grain of rice was considered one byte of data, a zettabyte of data would fill the Pacific Ocean. That's how much data these devices are going to generate. And Microsoft Advanced Analytics portfolio has the capabilities to build solutions based on all the way from processing data using open source tools such as Hadoop, Spark, and R-based analytics to the cognitive services and analytics APIs that will empower everyone from data engineers and data scientists to the citizen scientists to the developers and finally the business decision makers and technology decision makers. So in terms of our collaboration with the South Big Data Hub, you can watch out for a broad RFP that we are going to be rolling out in, I believe, the May newsletter, which will, I think, sometime next week, where in addition to some of the bigger grants that we are providing, some of the NSF, funded researchers, we are also opening it up to the broader South Big Data Hub community, and I'll let Leah sort of drive that, Leah and Renata drive that with the community. With that, we're at 1 o'clock, and if you have any questions, we're happy to take them now.
Yeah, so people open it up to questions. Take a moment to unmute your mic.
So this is Stan Ahalt. I have kind of a strange question, but hopefully it'll loosen other people up. So how can the South BD Hub be most helpful in helping Microsoft derive value from the donations of the resources that you all have put forward? What do you want to see come out of the your contributions to the Academy?
I think engagement is key, coming to events like this and being aware of what is available and being aware of how it is helping other academic communities sort of accelerate their research forward is key. It's something that what Microsoft has successfully done, what our team has successfully done over the past few years is bootstrapping academic communities with the cloud resources, and a significant amount of cloud. It's not trivial, it's not just a few weeks or a few months, but the awards that we give are good for a year and even beyond if it is something that if we see a need for extending an award, we do manage to sort of sponsor that beyond even 1 year's time. It's very empowering to even try this out and realize how powerful this can be to research and how easy it is to use. But you don't get there by not even trying, right? So engagement and just trying out some of these services is really helpful in, utilizing and leveraging the credits that we're donating to the South BD Hub.
Okay, that helps. Thank you.
Would other folks like to ask questions? Please jump in. Vani, will you maybe talk a little bit about the training we have planned on June 8th?
Yeah, sure. So we are co-locating our next training event in the South Big Data Hub along with the all-hands meeting, which is on June 9th. We're doing a training the day before the all-hands, and it's an all-day training, and it's mostly hands-on. It's a training that we do fairly regularly, and it's been very useful to everyone who comes to these sessions because they get a chance to try some of these services. We give $500 worth of Azure credits that is valid for up to a month after the training. It can go a really long way. You can try to even, start to prototype your research on this training path. So the topics we cover are around Azure storage, some of the big data, using Spark and Hadoop on Azure, using container services, using Azure Batch. All the training is on GitHub, and we have more, obviously we have more content than we can cover in one day, but it's a fairly intensive and fun way of learning how to use the cloud. So I would encourage you to invite your students and invite others, to this training. If they're going to be in Washington, D.C. for the all-hands, it's just an additional sort of day that they can get some real hands-on experience using the cloud.
Yeah, and it's free to Hub members, so we highly encourage people to participate. It'll be at the Microsoft Pavilion in Friendship Heights, which is right off the metro.
And one thing, excuse me, we can invite people to do, since the training, as Vani said, is very hands-on. Just ask any students or whomever that comes to bring a laptop with them. They don't have to have anything installed on that laptop, and it doesn't have to be a Windows laptop either. It can be a MacBook or a Linux machine if they want. When we build the training content, we work very hard to make sure that it will run on any platform, just as Azure will.
Yeah, we're very sensitive to the fact that we have to be 100% open source and platform agnostic in terms of teaching people how to use the cloud, and we emphasize those aspects and pretty much, do not use any content, which sometimes some of the newer services gets rolled out to Windows first and then to Linux and Mac, and we make sure that we're using services that are mature enough and are available on Mac and Linux.
Does anyone else have questions? Does anyone have questions for all of our speakers?
I would like to say thank you very much. I'm really fascinated by both of the presentations. I thought they were excellent. And I'm going to go sign up for Globus, and I'm going to be at the Microsoft Azure training in D.C., and I'm eagerly looking forward to it. I did not realize you all had as many APIs created as you were just now showing, and some of it really looks interesting, including perhaps for classes. So thank you very much.
Yeah, thank you. We look forward to meeting you there.
Yes.
Yeah, so thank you, everyone. I know it's 4 o'clock on a